Hello, I'm Andrew Smith from the Open University Cisco Academy, and I'm going to be covering Module 9, First Hop Redundancy Protocol Concepts, as part of our TM257 Cisco Networking, as part of Switching Routing Wireless Essentials. As ever, I am not going to be reading through the slides verbatim. I'm just going to be exploring the content with you as a high-level overview. This is probably one of those more useful topics in everyday networking. The challenge for networkers is, what happens if the default gateway fails? What happens if my route to exit the network is unreliable or unavailable? And the solution is to have multiple default gateway exit points, but only one that the device knows about. So we can have many exits, but only one IP address that it knows it's the exit. Most clients will only know one exit point. There is only one default gateway or default router, but we can actually create multiple devices. But then each of those devices are responsible for owning that exit point. And one will always be the exit point. You can have exit points per subnet or exit points per VLAN, but you can then ensure that in the case of failure, another exit point will quickly become available on a network. And that is first hop redundancy protocols in a nutshell. What happens when it fails? And it does this by having each IP address is still bound to a MAC address of an interface of a router, but then what we do with the virtual IP address in the ARP tables is say, right, this is the preferential address. This is the address. So if I have 10.0.0.123 as exit points, physical exit points, but I have 10.0.0.254 as the default gateway. Physically, it doesn't exist. But I tell the local host, the device on the network, that mine, which might be 10.2, is the preferred exit point. And then there is a negotiative protocol that handles which one is going to be in charge in case of failure, or which one is going to be the failover in case of failure. And we create what is in effect a virtual router. Well, no, it's physical. It's just that one holds the flag and says, it's my turn to be the default gateway. And basically, a lot of the stuff you're going to be reading about is how router redundancy protocols handle this failover methodology. And there are lots of them, okay? Now, you're going to learn about hot standby. That's the Cisco proprietary one, and in NetAcad, it is actually quite a straightforward one to configure. If you're a TM257 student, we do ask you to go and do a little bit of research on the other ones, and I think that is quite a useful thing to do because we are in a multi-vendor environment, and you may have to use FHRP or GLBP instead of hot standby, but the principles are pretty much the same. Okay, it's pretty much, and you'll find that systems like FHRP actually work on Cisco routers as well. So you can go and do a little bit of Google research and look at how to set those commands as well. So my advice is, from a CCNA perspective, and from a certification perspective, and from a module perspective, get to know hot standby, but from a professional perspective, do some research and discover what the others do as well, because you'll find that's very useful, and we do encourage that research within our module. So the rest of this is Cisco proprietary, not the air quotes, because it will teach you all the others, and we will look at hot standby routing protocol, which is a Cisco proprietary first hop redundancy protocol. I love sometimes how these acronyms are a bit of a mouthful. As you probably discovered on my previous video for Slack, I was getting myself into a little bit of a knot trying to say some of these things. So how Hot Standby Router Protocol worked, or HSRP, is it has priority and preemption. So one router will gain priority either by your control or randomly, based on different addressing methodologies, but the default is 100. You can set it high, you can set it low, and you should decide which device, usually the preferential device with the preferential connection, gets to take the lead. But with preemption, then if there is a failure, then the re-election takes place, and that way then if a new device comes along, we can actually ensure that the higher priority always wins. So if you have preempt set up, one fails and everyone's got preempt priority, it will say no, I've got the preference. And that's just in case somebody has set up other devices on the system. However, it will assure higher priority, but if you don't have preempt, then any other device with a priority, sufficient priority, will take place and take precedence. And that means then that you could have poor performance. However, any connection is better than no connection for some clients whilst you're going and fixing the router that has fallen out of the system. HSRP goes through a range of different states, and you need to understand that as soon as it starts, it goes through an initial learn and listen state, and then whatever those modes are, and it stays in those modes, it is not the virtual router. It will regularly speak and send out hellos and say I'm available, and listen for who else is available on the system as well. If it's listening, it should be in control and able to sort of communicate. And if it's on standby, it's waiting for other routers to actually fail before it comes into action as well. And I think the beauty is actually to do this packet tracer activity. Well, actually, these two packet tracer activity, well, you'll actually see it in action. And my advice is to ping across the system. I'm going to do a short demo after this video, which will actually probably help you see what has taken place. And I'm actually going to do it with 3 routers. So, thank you very much. I'm Andrew Smith from the Open University, and this very short and brief and sweet slide presentation should have been quite useful for you.